Alrighty, so let's finish up here by taking a look at the west facade for our example building. This is the last facade that we have to do. I know it's been a long series of videos, a lot of data to enter. I know that, but we're down to the last bit here. So let's just take a look at what it's gonna take to model out our last few window units here. For the most part, the window units are pretty straightforward. We've got tilt turn windows, no moles on this side, which is great. But we do have one new window type or door type that we want to model in here. So we have to build one last frame type, and then we can go ahead and finish off all of our window elements here. So the new frame type, the one last frame type, of course, is for our swinging door. So let me bring back our example files. So the example file set that we've been working with, let me pull that back in. And so far, of course, we have modeled our Purista, our tilt-turn windows, and our Motura, our lift end slides. So the last one that we want to model here is going to be this Entrada door. So let me double click on this and we'll open up our Passivhaus certificate here. And we have already seen this a few times, but this is our entry door, a swinging entry door, in-swing entry door here. And as with all of the other products that we have looked at, if we scroll down a little bit, the important bit here for our purposes is going to be all of this performance data here. So we've got all of our frame widths, our U values, our side glazing edge for all the different sides and edges. So let me pull this off to the side and let's see if we can finish up building or we'll build the last of our little sets here. So let me, I guess, zoom out a bit here. I'll try and get everything on the screen all at once. There we go. All right. So I'm back in my components worksheet here. So I'm in my components worksheet, and we can we'll go back to our where we were in our window frames section of the worksheet here, and as always, we will start with the UF values, so the various U values for the different edges, and we could certainly model in one of these open slots. I'll skip another slot here just to kind of keep things roughly grouped together. And so let's give this a name. We'll say OptiWin. What is this? The Entrada. And this is a swinging door. Swinging door. Just for clarity, add that in. All right, and so always, as always, we'll go left, right, bottom, and top. So the U value of the left side, so U value of the left side will come up here. So left slide, let's go back to our diagram for just a second. So left slide, in this case, will be the handle side. So the handle side, notice if we go to our document here, we have a hinge side and a lock side for the two sides. So a slightly different U value for those two. So for the handle side or the lock side, we'll have a U value of 0.76. So we'll go back to our conversion tool. I've got my conversion tool open here as always, and we'll go to our transmittance 0.76. And I'll enter that, and so we get a U value of 0.134 in IP. So I'll come back here for my swinging door, 0.134 for the lock side or the handle side. All right, fine. So what about the right-hand side? So the right-hand side, of course, the hinge side here, and we'll get the hinge side, so 0.74, so slightly different U value, 0.74, and that gives me a U value of 0.13. So I'll come back up here, and 0.13, and there we go. Now the bottom, the sill, obviously the sill is going to be very different for a door. Door sill is going to be very, very distinctive, very different than a typical frame element. So up here we can see the threshold has a U value of 1.02. So we'll come down here and we'll see we have a 1.02. What does that give us in IP? 0.179, 0.18. So we'll go ahead and put that in, 0.18. And then lastly, the top, so the top 0.74, again, the same as our hinge side. And what did we say that was? I've already forgotten. 0.74. That was, oh yeah, 0.13. So there we go, 0.13. All right, so there are our four UF values. Again, just taking them off the table of values right here, one element at a time. All right, so let's put in our frame width. So we'll do left, right, bottom, and top. And so the lock side, the left side, 189 millimeters. Let me scroll up in my conversion tool here to the millimeter section. So 189, so quite a bit bigger as a frame, stands to reason, right? A glazed door like that can have quite a big frame element. 7.44 inches, so that's a big one for sure. 7.44 inches, and that's going to be the same for the right-hand side as well. So the lock side and the hinge side, notice they have the same width, even though they do have different U values. So different hardware, different component pieces are going to affect those two different sides differently in terms of heat loss, even though they do have the same physical size. So 7.44 for both of those. Notice here the top, while we're at it, the top has 189 as well. So we can go ahead and put in our 7.44 for the top, just for efficiency there. And then the threshold, 170 millimeters for the threshold. So a little bit smaller on the threshold, which is interesting. Usually the thresholds are bigger, but in this case, 6.69 inches for the threshold. So 6.69 inches for the threshold element. All right, last couple pieces that we need to put in are SI glazing edge, so the SI spacer here. Notice we have 0.022 for everything. So that's convenient. We can use the same 0.022 for everything. Let me scroll back down to our SI value conversion. There we go. SI value 0.022. Convert that. What do we get? 0.0127. 0.0127. And because we have the same value everywhere, I can just grab that and I can propagate that across for all of those, right? We have the same 0.022 for everything on the list. And the very last thing, what are we going to put for our SI install? Well, I am going to go ahead and grab these. I'll say copy, say paste special values, say OK. We use any of our normal Excel tools. I could use the propagate tool. I can copy and paste. I can copy, paste special. We can use all the basic Excel tools there. But we're going to use the typical default SI install values. As always, we can come back and we can refine those values later on once we start getting into thermal bridging. So we'll come back and talk about that in later sessions. For now, though, we have all of the frame elements built. So that was the last, go back to our drawing, that was the last new frame type that we needed to capture here. So we have our typical tilt-turn windows, and then we have our new swinging door. So let's go ahead and finish off our window modeling by just tagging all of these west side units. So let me pull this off to the side a little bit so that we can kind of see this as we're modeling. And I'm going to go from the components worksheet over to the Windows worksheet. So I'm going to jump over to the Windows worksheet. And I'm going to scroll down to my west side. So I've got my west windows, and as always, we'll go left to right. We'll start on the first floor, window 1.1, and then we'll work our way up to the second story. So west window, floor 1, unit number 1, that is a typical tilt-turn window. So I'll come in here, and I'll just go to my frame drop-down, and I'll select the typical OptiWin Purista tilt-turn off of the list there, and notice that that gets filled in. Now, the other thing that we want to do, of course, is we want to tag our install situations, our left, right, top, and bottom. Well, this is a normal install for all 4 edges. So left, right, top, and bottom, those are all going to get a 1 when it comes to the install situation. So I'm going to go ahead and put a 1 for all of those. This is installed on all 4 edges. And there we go. Okay. So our west door, floor 1, unit number 1, and this is going to be our swinging door. So here we go, our OptiWin Entrada swinging door. I'll go ahead and assign that there. This one is also a 1111. That meaning that it is installed on all 4 sides. So I'll go ahead and just propagate that down. And now our second floor, west window 2.1 and west window 2.2, those are both the tilt turn. So I'll go ahead and apply that tilt turn type to both of those guys. And these are also all installed on all 4 sides. So I will just propagate the 1s all the way through. Notice this quite a simple elevation compared to the east and west where we had all those mold situations and the like. Alrighty. And now if we expand out our window worksheet here a little bit so that we can see a lot more, notice that all of our windows are working. We can tell they're working because we are getting good results over here on the right-hand side. Notice that we are calculating UW installed values. We're getting anywhere from 0.0 0.13 up to 0.17, some 0.16s. So as we've talked about in the PHPP, the UW installed gets calculated uniquely for every single window unit. Very different than the typical NFRC process, where we have a single U value that gets applied to all units, regardless of size or frame type or install situation, etc. So a lot more detail and nuance being captured here in the PHPP, but obviously a lot more data entry and a lot more information is required of us when modeling these windows in the PHPP. So we have successfully modeled all of the windows. We've built all of the frame sizes. We've entered all the performance data. We have tagged all of the windows with all the frame types. And of course, before that, we built out all of our glazing types and we tagged all the surfaces with glazing types. And before that, we entered all the geometry for all the windows. It's a lot of information for us to enter for all of these windows. The other piece to just flag here, and I know I have mentioned this before, all of the numbers that we've been entering are really quite weird. They're they are not at all human scaled, with the exception of maybe the inch values that we put in. 0.022, 0.0127 versus 0.0134. These are very weird numbers. And the reason I bring it up is I just want to stress it's really easy to make a mistake. It is incredibly easy to make a mistake. Put a decimal in the wrong place, be off by a hundredth or thousandth of a BTU per hour per linear foot degree Fahrenheit. It's very, 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 very common and very easy to make a mistake with all of this data entry. So my recommendation to you is attempt to put in place some mechanism for quality control and evaluation of your data entry and your work on these pages, the components pages and the window pages. And we will see in the next series of videos when it comes to shading as well. These are the sections of the PHPP where we very, very commonly see people do things wrong, where we in our office very commonly do things wrong. And the only way we notice that we've done them wrong is because we go through some sort of quality assurance or quality check process that we've had to implement internally to make sure that these things are being done correctly. Again, it's very, very, very easy to do this wrong, and important that you put in place some sort of checks or sort of quality assurance procedure to make sure that stuff is being captured correctly, because obviously a tremendous amount of data, a lot of places to go wrong with this type of data entry. Now, of course, we will also talk in future videos about some methods for automation of this entire process. Obviously, in this class, we are doing all of the data entry manually, which, of course, is a valid method. It is a method that many Passive House practitioners use. But there are some very good tools to automate this process, to capture all of this data from things like 3D models and building information models. And of course, we'll have plenty of time to talk about that in the future. But this is a process which many people have done manually in just this way for many, many years, and many practitioners still work this way. And so it's useful to understand this process, even if you are going to be using some sort of automated or building information tool in the future to do a lot of this data entry automatically. Useful to understand what we're trying to achieve here. So with that, we are finally at the end of our window components input section. So we have, as I said, successfully modeled all of our windows here. All of our windows are operational. We're calculating UW installed values. They're flowing through into the heat loss section. And in fact, they're even calculating solar gain at this point. Although we have not yet talked about solar gain, we have not yet input any information for shading. If we were to go off and look at our assessment results right now, we would see that there is some solar gain coming in, but don't pay too much attention to it yet. We haven't entered any information around shading. So when we come back in the next series of videos, that is what we will turn our attention to. We will finally turn away from the question of heat loss and start looking at heat gain. We'll start looking at solar radiation in general, and in particular, we'll launch into an extended discussion of shading, and we'll look at how shading is implemented in the PHPP. We'll talk about a couple different methods for inputting and calculating shading factors. So again, thanks for all your patience. I know this was a long series of videos. Hopefully it is all making sense, though. Hopefully you are able to catch up. Hopefully you're getting some values which are at least a little bit like the ones that you're seeing on my screen here. Hopefully yours are pretty close. If not, if you are seeing some anomalous results, see if you can find where those discrepancies are occurring, and see if you can identify where things went awry there. So I will close this video here, and I'll look forward to seeing everyone back in the next series where, as I said, we will turn our attention finally towards the question of shading and solar gain.